All right, I had said this at the top that, on the one hand, it's been dtrace has broadly worked. We haven't had too many bugs, but we have had some. In particular, we had a bug that goes back to the very, very beginning of dtrace. Adam had mentioned, we were talking USDT, had mentioned briefly STT, which is one of our earliest providers. And Luqman and Kyle working together discovered kind of a gnarly issue. And what like I said, one that dates back to dtrace's origin. So, Luqman, you wanna take it away with a tale of finding a bug in dtrace itself?
Sure.
Yeah.
Yeah. And I don't have any slides for this, so we'll just kind of be looking at maybe some code and maybe some. Let me find this bug. Which window? Yeah. So this was actually discovered by my colleague Kyle, presented earlier, and while refactoring OPTE and specifically XDE, which is the kernel module that actually uses the oxide packet transformation engine. And since it runs in a kernel context, we use SDT probes. And as part of our like refactoring and working on some other issues, Gal was running into these panics, which is just like were very weird kind of stack traces. That was like, how on earth did you kind of end up in there? And at some point, realize, oh, turns out at some maybe I think I don't know if there was also a tool chain upgrade involved, but at some point, those probes had become tail calls instead, which was causing some havoc. And maybe to explain some of that here, actually, we'll take a look at what these STT probes end up looking like.
And Bookman, this is not panics when using dtrace. This is
Oh,
panics when executing the system
yeah,
without. It's like even worse than dtrace dying when you run it. Dtrace is so yeah. Just to
yeah.
set the
Like you
context.
didn't even have to, like register a particular probe or anything. It's just once it got to that point where the probe would be fired, and then after that. And to kind of explain what was going on here, so this is an example of these STT probes. In C, they end up kind of you use these macros to generate them, and basically this kind of expands into something um, prefix of what underscore underscore dtrace, and then the name of your probe, and then um, it turns into a function call. So if we actually look at this, what this looked like on disk, this is something that's included on the system here. And so if we look, it's like, yeah, so we do a call. We're calling this function. And you can actually see right underneath here, there's this relocation with this, like that fake function that it had generated because it's like, actually, I don't know where this function is. So it's all zeros. It'll get filled in at runtime. And just for reference, what a tail call version looks like is more or less the same, except instead of a call, you have a jump um, with nothing after it. And at runtime, once you actually load this, the kernel runtime loader will fill in. Well, if it was a normal function, it would fill in that offset. But in this case, instead, it just patches all those to knobs. And similarly for the tail call version, well, now you actually see that its fixers are right at the bottom, but before these were all just a bunch of knobs. Um, and so what was happening was it would get to this point, this kind of function, the probe would fire, and you just kind of continue on to the next, like whatever could happen to be after that, which, explain the weird stack traces because it's like, how did you end up in this function here? And now all of a sudden, these invariants that should be held in a normal function call are no longer held. And eventually it led to some kind of panic. Um, so I mean, the fix here is basically just patching in that red so that it actually properly returns from this function and continues on. And you can take a look at what it looks like actually also when you register for, like, let's say I want to get the test stars one, the non-tail call version. If I disassemble an app, also this is in an MDB session, so this is kind of live. And you can see actually it patched it to a lock knob. So this will trigger, I believe, like the undefined function handler, which eventually makes its way to firing the actual probe. And, if I run this thing now, which fires the probe, hey, actually, this one should have never panicked, but the tail call version similarly should now also be patched. Well, actually, like, yeah, this one is no longer patched because I'm no longer asking for that one. But if I look at the tail call version, now it's the one that has the lock knob. And same if I run it, it's not panicking anymore, which is great. So that was kind of an interesting thing to figure out. And then the other interesting part was this is the code where in the kernel runtime loader, and this is actually the Spark version. And I saw this and I'm like, hey, this sounds very much like what should be happening, except it wasn't happening on the x86 handler until it got updated. Um, but yeah, that's kind of the quick of it. Very last minute. So there's no slides or anything, but yeah.
Well, that is great, and this is definitely, I think, 100% on. I haven't actually gone through the history to confirm this, but I think we can say with confidence that this is on me.
Well, I mean, the surrounding code looks like has not been touched in like 20 years.
Yeah, right.
It's the
But
worst.
I mean, it is, and the question in the chat was like, well, how you never hit this? And yeah,
Oh, right. So I ran into this while I was adding a test. Turns out, like in the kernel, we just have no optimized symbol calls. So there are no STT pro points that were like tail called in that way, at least in tree. Um, so like we just never hit it in like all the kernel modules that are just already included in the Illumos tree. And XTE it's like, developed outside of that. Also, it's in Rust, different tool chain, different rearranging the code. We just happened to hit it at that point.
and it's actually, it's kind of a great thing about having, now having Rust in the kernel allows us to get a whole bunch of different, exposure, and it's been very, yeah, the okay, I know this is good. This is a bad look. There's a question in the chat of like, didn't Ben talk at a conference about finding some of the zero day initiative discoveries for dtrace? Yes, that was in 2016. Yes, those are the videos that have been lost. Yes, that's a bad look, but it's like, but so unfortunately, I would love to recover those videos because of that. But um, part of what actually that's right. Feels. Do I need to have my lawyer? Actually, you know what? I do have my. Fortunately, it's also my financial advisor and personal physician, in addition to hardware engineer. Um, Adam Leventhal advises me not to answer. Yeah, use of Vimeo, totally. And actually those vulnerabilities were part of what drove me personally to Rust, because it was the vulnerabilities were somewhat chilling in that it was an easy mistake to make in C. But that's not what this is. This is more just I'm not even going to try to explain myself on this one. I'm just going to throw myself on the mercy of the court. And Luqman, thank you very much for debugging this and debugging a 20-year-old bug, and getting it fixed.
Not just that, but also I love that you pulled up like the Spark implementation, which describes handling of tail calls.
Yeah.
Just the,
Whose lawyer are you anyway?
the restore followed by the call followed by the restore, like brings me back in terms of like the restore and delay slot. Like those are a simpler time.
Yeah, it's like, yeah, if we must patch the arrest. Like, yeah, that's what we need to do.
Awesome.
Cool.
Yeah. And right. And someone was saying how generally your probes would be kind of in the middle of the function. I think we were seeing this especially because we had like some kind of little functions like this that basically ended up being wrappers for the probes where they would just do the probe. I believe I'd have to go look at how OPT did it, but like they just worked out in such a way that, yeah, the probe is at the very end of this call of this function. And because of, now that I think Kyle had said something, yeah, like they didn't need drop anymore. So all of a sudden they became eligible to be tail called in this context and trigger the bug. Fun. Yeah.
Very cool.
Awesome. Well, thanks again, Luqman, and thanks for debugging that and fixing it. Really appreciate it.
Everyone.
Um,
Thanks.
well,